Oh, g'day, champions. Just a quickie on this one. This is a Laboga Alligator. Alligator. It's a bit of a weird amp. I was getting a bit confused by the fact that when I turned down the master volume, which is a post-phase inverter master volume, I was getting more and more clipping. Normally that's not how it generally works. The job of a post-phase inverter master volume is so you can crank the signal up. The signals in the amp are insanely high up to the phase inverter, and it starts to clip the phase inverter, and then you're controlling the overall volume of that phase inverter hitting the wall. So you're changing the amount of distorted signal from the phase inverter to the output valves. In this amplifier, even when I scoped it upstream, as I turned down the post-phase inverter master volume, the preamp started distorting more, or not preamp, but just before the phase inverter. So that made me look deeper at the circuit and scope the thing to try and figure out what's going on, because, you know, it's not like I'm paid by the hour or anything. Sometimes stranger designs get the better of me, and I need to know how they work, and I don't charge the customer for that time, obviously. I pull out the schematic and scratch my noggin a bit, and this is what I found.
Alright, champions, here's a schematic. You've got your power supply here, your relay circuitry with your channel switching here. This is the circuit of your various foot switches. There's probably two models. We've got one with LEDs, one without. Here's your preamp. You can see the sort of pedally type diode clipping gear over here. And there's some FET switching for your lead gain to enable that. I sort of refer to these amps as like a 1.5 channel amp because it's not two independent channels switched between two signal paths. It's switchable, essentially mods happening throughout the signal chain in the single channel. A little bit like Mesa Boogies, a few other brands do similar stuff. So they must have a model that's got two EQs, one for clean, one for drive. Our particular model here just has the one EQ that covers both channels. Up to page 1 where the important shit is. So here's the input from the preamp output. It comes through a buffer, unity gain. You can see there by the feedback loop. It's got your send and return for your effects loop. It's got effects loop bypass switch, and it's got a voltage divider, and then it's got your reverb circuitry. So you got your reverb pan in there. Well, not pan so much, but you know, your little springy chucher that's I showed you mounted inside, glued to the circuit board components, which is not smart. That feeds out here. You got a reverb foot switch that when it's switched off will shunt that signal return to ground. You got your reverb output pot there, so that's essentially a voltage divider, and that's going via these two resistors to this relay. This relay is currently shown in lead mode. So they've actively gone out of their way to trim the reverb return when you're in lead mode and have it full belt when you're in clean mode, because then those two resistors would be in series when the relay switched into clean. It'd be up to this contact. You'd have less resistance in series to where it injects into this weird circuitry. Now you can see here your dry signal pre-reverb comes down via this 470 nano cap into this circuitry input here. You got a trimmer there, which essentially changes the bias point of this. You can see here it pulls a line from the 8 ohm tap on the output transformer that feeds to the essentially pseudo balanced DI output. It continues up here and then feeds into the same point as the reverb signal. And this is essentially a pretty complex circuit. I'd have to sort of model it to fully understand it. I'm a bit of a dumbass at the best of times, but essentially what I gained from scoping it out is when there's bugger all signal here, this is technical terminology, mind you, when there's not much signal coming back from this feedback line, and that's post-phase inverter master volume, which is there, it feeds back through here, and essentially this transistor here, this stage, chops off, it sort of throws it into cutoff and chops off one side of the waveform there, and then chops off the other side of the waveform at this stage. So when you scope at this point, was it this point? No, that point, one half of the waveform's chopped off, and when you scope at this point, both halves of the waveform are chopped off, and that amount varies according to the amount of signal that's coming back through this line here. So pretty weird circuit. Like I say, I'll probably have to like model it in Spice or something to fully understand it, because I ain't the smartest bear going around. You don't have to be a genius to fix stuff. But, you know, to design this thing from scratch and make it do what it did, it's either a lot of empirical work or someone that really knows what they're doing design-wise. However, the overall end result is kind of dumb and kind of useless. So if I owned this amp, I'd probably just play with the post-phase inverter master volume maxed out all the time. And just to take this thing sort of out of the equation, or you could just bypass it completely if you wanted to, because it kind of defeats the purpose of a master volume post-phase inverter. I don't know. It's a weird thing. They seem to be highly sought after, but I mean, they sound okay. It's a bit of a weird solution for a question no one asked. I guess the premise is, right, if you're turning down your post-phase inverter master volume, that you want some overdrive at lower volumes, yeah? Like, that's the logical reason for turning down a post-phase inverter master volume, is to get distortion at lower volumes. But they're doing it the way that it's not, like, you don't introduce clipping in, I don't know, it's just... Do you get what I mean? It's like it defeats the purpose of it. It's like it's a little bit like in the modern cars where when you put your foot down on the accelerator, it just gives you a signal on the speaker that sounds like an engine revving. You know what I mean? It's like when I put the foot down, I want it to do the thing that it does when you put the foot down, right? So this is like, although they've got everything here to do what they're simulating, they're still simulating it. And it just doesn't make a hell of a lot of sense. But to be fair, this is a cathode phase inverter with no grid stopper. So if you did overdrive that, it'd probably sound like an arse anyway. So, and it wouldn't be trivial to insert a grid stopper there because it's a circuit board mounted valve socket. So there you go.
So this one, like many amplifiers, came in with one symptom being caused by 3 or 4 stacked up different problems. So the effects loop was intermittent. The loopback jack that is on the effects return that would normally shunt the signal through, that shunt contact had fatigued and was no longer reliable. Just tapping around that area cut the signal out and distorted it. So that had to be replaced. The same deal with 2 of the relays. First one I thought solved the problem, and then when I put it back in the cabinet, the vibration from the speaker was making the second relay intermittent, and actually under high volume it sounded almost like arcing because it was like a heavy distortion right at the peaks of the waveform when the vibration was the most. However, as soon as I took it out of the cabinet, that ceased to occur, so that made me think it was vibration. So tapping around a little bit more, I found one of the relays was sensitive. And what a convenient place to put your relays, under a reverb unit that's glued with foam, which is glued to the PCB, and that foam is glued over existing components. So, you know, again, boutique amps really dropping the ball. These boutique manufacturers often don't have anyone to answer to, so you end up with weird designs like that. If they had a repair and service department in-house, the service tech will go, whoa, hold on there, partner. You don't want to be doing that shit. So reportedly, from the customer, he said the market price of these is about $4,500. I'll have a look online and confirm that. And for that price, you get pretty cheap single-sided circuit boards, well laid out, large pads, large fat traces, looks like pretty thick copper, but nonetheless non-through-hole plated single-sided PCBs. Sort of the same style PCB that's in like PVs and stuff. So I think for the price, you'd like to see a little bit better than that, wouldn't you? But I digress. I do that a lot these days. So once I sorted out the jack and the 2 relays, I realised there was no reverb send. So there was reverb recovery. I could touch the springs and that made it through to the output signal, but no send. So I tracked that down to U1 having a failed B op amp. So that's a dual op amp. So the second op amp had failed. So it had input but no output. So I replaced that and she came back to life. And once I did all that, I found thunderstormy sort of sounds in the background, bit of crackling, intermittent, and tracked that down to the phase inverter valve, which was a JJ's from the customer, reportedly from the factory. So she's had a good run. She's got a new JJ's in there now and all that crackling's gone away. So we've nailed all those issues, but then I put it back together and realized that when the master volume was anything but max, there was no clean headroom on the clean channel. It would start to distort it like 2 or 3 on the control. But when the master volume was wide open, you could crank that clean all the way up to 10, 100%, and there was no distortion, at least with the pickups I've got in this Strat in the workshop. So I thought, what the hell? I thought initially it might have been a negative feedback issue or something, so I isolated that. However, the deeper I dug, I found a schematic. I had a look at the feedback circuitry on there, and it wasn't your average setup. Now, the distortion on the lead channel on this is derived from op amps, sort of like a pedal, so you sort of get that slightly filtered, kind of homogenized pedal distortion sound. You guys know what I'm talking about, I assume. Slightly less excitement, less, what buzzwords can I use? Less edgy than amp distortion. It's sort of a more smooth, homogeneous sort of tone, which suits some styles well, but I find it a bit less exciting personally, a little bit less intuitive. Almost like riding like a fly-by-wire motorcycle instead of like a flat slide carby on a race bike, you know? You get that instant feedback. Alright, champions, so I'm looking at the signal before this weird circuit on the top trace. I'm looking at the output signal on the bottom trace, so that's from the speaker on a dummy load, and that's from the input of R52, which is just prior to the effects loop. So this should be completely unaffected signal, and then this is showing the clipping at work, and then I'll show you how the clipping circuit functions. Alright, so there's the signal at R52 up the top. It's about 2 volts peak to peak, and the output, as I bring the master up, so that volume is set, the clean volume, so essentially the gain control is set to 12 o'clock, so 50%. And now I'm just bringing up the master, and you can see that it's almost like the diode clamping, and now it's clean, and that's with the master maxed out. Now if I max out the master and then bring up the clean, it's clean all the way up until you get output stage distortion. You can see the signal upstream continuing to increase, and we're just overdriving the output stage. Now we know we're overdriving the output stage because you can see the bias excursion there with the crossover, little crossover step. So that looks to me like it's not distorting the phase inverter at all up to that point. Now if I put the master at 12 o'clock, bring the clean up, you can see it cuts off there. Hits a wall. Now I've got the master set at 30%, and I'm probing just before the phase inverter, so R64, which is just prior to the input coupling cap feeding into the grid of the cathode ion phase inverter. As I bring up the clean gain, you can see it clamps there, and of course that's represented on the output as well. We'll bring that down to the level it was before. So we're clamping at that point at about 25 volts peak to peak. Now as I bring the master up, remember post phase inverter master volume, you notice it cleans up and the signal reduces upstream. So that's what was confusing me. And if I turn the master all the way up, it doesn't clamp, and the level is reduced at that point. So that's the effect of that strange circuit. So now I know. I'll be less confused if I ever see one of these again. But with the massive amount of different manufacturers and amplifier designs, you kind of can't beat yourself up a bit too much if you see something a bit strange like this you've never seen before, and it takes you a second to figure out what the hell's going on. But I just thought I'd share that with you, so if anyone else gets confused by that circuit, at least you know its function, or what it should be doing, and that hopefully helps you out to diagnose it a bit quicker. So thanks for joining us, champions. Like, subscribe, or I'll send you flaming bags of poo. All right, or I'll start ordering the town's worst pizza to your house every weekend, and you know, maybe kick your letterbox over. So to avoid that, like and subscribe, and I'll see you on the next one.